Hi guys, what I want to talk about today is a digital height gauge that I've just made, and I also want to talk about the bluing or blackening of the components, which has worked quite well, and that's the main thrust of the video. Okay, so the construction is pretty simple. We'll just dismantle it and then reassemble it so that you can get an idea of the various components. So I'll just undo the foot here. So the heart of the unit is this digital Chinese digital gauge. I think it was $30. It doesn't actually say where it's made, but at that price it's got to be made in China. It's as accurate as my Mitutoyo. The disadvantages with it, when I got it, it was pretty rough and graunchy to operate, so I pulled the whole thing down and polished all of the ways with steel wool and Scotch-Brite, and so it's much smoother now. You'll notice that I've cut that arm off. I've cut the end off that arm there and removed the back of the gauge for this purpose. The other disadvantage with this unit is when you turn it off to conserve battery life, the moment you move it again, the display comes on, and that's a real nuisance. So I would rather decide when I turn it on rather than have this thing decide when it turns on and off. So that is a problem, and when you put it away, you've got to be careful that you don't turn it on by mistake, because the battery life is not quite as good as it could be. Right, so the base is a piece of aluminium which machined up. I tried to match that curve with the side of the base, not terribly successfully, but it's close enough. Couple of mistakes. I should have made this out of steel rather than alloy, but I had some aluminium available. And the other mistake I made is I cut the slot here to tighten up on the gauge in the wrong place. I should have in fact cut that slot through here. When I built it, I assumed that there'd be enough movement in the metal to clamp the gauge. There wasn't, so I cut that slot there, and then later on realised that I should have cut it in this direction, and I may still do that, although it does clamp up quite nicely anyway. The base, you can see that's sucked onto it, that's almost floating there, and it sucks on when I lift it up. This is just a piece of 1018, I think, I can't remember now, and I ground this on the surface grinder, not in the parallel manner, but by rotating this on the base. So I ground that surface first, then ground this surface, did a cut in that direction, rotated, did a cut, rotated, did a grind, rotate, and you can see the pattern on here, and supposedly that gives a much flatter surface, and it is quite good, because it's just about floating on the surface plate. So the base clamps onto here. I don't normally assemble things on my surface plate, but in fact I will put some protection in there while we're doing that. And the gauge clamps up like so. I won't do these tight yet because I've got to adjust them on the plate later to get everything square. The foot is a piece of 4mm gauge plate shaped in the mill, and I heated that tip up red hot and quenched it. So that tip is glass hard, progressing softer back to the temper as supplied here, and it clamps onto the gauge. Now I was actually going to drill a slot and a hole in here, and likewise on the foot, so that I could adjust the foot. The blue book came with this dial gauge, with this calipers, said that this was hardened, and believe you me, it is. I don't have a tungsten carbide drill the right size, but with some very sharp ordinary drills I could not make an impression on that stainless, so hence this clamp arrangement here. So the way that I assemble it is to get the foot flat on the surface plate. And as you can see, that's probably could be a little tighter. The foot's now flat on the plate. And that's it. I have done some measurements on a milling parallel, and then mic'd it afterwards, and the results are within 1/100 of a millimetre. So I'm quite pleased with the way with the accuracy. The reason that I've mounted this off centre is so that I can use it as a mount for a magnetic base, and it is quite useful. It has proven quite useful. Now the other thing I want to talk about is this is the chemical bluing, or the chemical blackening, that I used to treat this metal. So I'll get rid of this, and we'll do another do some more blackening. Now the chemicals that I've used is this a gun blue cream, which I bought from Brownells about 40 odd years ago. It was $10.50 at the time. It's so old that the label has faded, and I can't quite read the directions, except it says contains selenium, nitric acid and copper nitrate. There won't be much nitric acid left in there now, because nitric acid is volatile, and when I opened the container a few days ago, all that was in here were the copper nitrate crystals and the selenium. However, so I added some boiling water, and it is working very well. So what I'm going to do is blue another piece of metal. So I'm going to pour a couple of mils into this yogurt container. It doesn't need very much at all. So you saw how little I poured in there, and I've got a toothbrush, so that's the quantity I've got in the container. Now I haven't degreased this, because using a toothbrush and scrubbing action, I've found that you don't need to. So this is a nose attachment for my lathe for some ER collets, so there's a taper there, and this has been in the raw, and I've used this for quite some time. So I'm just going to show you how well this works. So I haven't degreased this. One should degrease it with the brake cleaner or something similar, but I have found that it actually isn't necessary, because if you simply dampen a rag with a solvent like brake cleaner and clean your workpiece, all you're really doing is distributing the grease over the product. Because the brake cleaner is dissolving the grease, it's still on your piece of paper or on your piece of rag, and all you're doing is wiping, is diluting it and spreading it over the workpiece. Now, this is not going quite as quickly as it would have if I'd degreased it, but the scrubbing action with the toothbrush is actually getting through the oily surface, and this, I have not cleaned this. This is simply as it came off the lathe. So I've been handling it with the greasy fingerprints and oil. Okay, there's a bit of a patch there that doesn't, it's not coming up quite as dark as the rest of it, but you know, given the effort involved and the time this has taken, I'm not going to do the threads on the inside. Now, if you read the internet, they say that selenium is intensely poisonous. That's not quite true. The oral dose required to cause a problem is about 5 milligrams, which is actually quite a bit. Right, so I'm just going to wash this in hot water and then we'll oil it and see what it looks like. It's actually quite convenient having a hot water supply in the workshop. Right, so that's straight out from under the hot tap. Now I'll put some, oil it, and the oil is important because all blackening is etching of the surface of the of your metal. So if we were to look at this with a microscope, it would resemble a sponge, I suppose, is a good way of putting it. So the surface has got a very fine, is now a very fine porous layer, and that helps trap the oil and keep the oil in contact with the metal. So it doesn't make it rust proof, but it makes it rust resistant. And of course it looks quite nice. So there we have it. Now there's a little bit of a surface there which is not quite as good as the rest of it. So what I'm going to do now is do another piece, but this time I'm going to wash it with brake cleaner. So I'm just going to go and wash my hands with some soapy water. I'll discard that oily rag. We'll get a clean rag, and then we'll do the bluing of another piece. But this time I'll wash it down with brake cleaner. Right, so this is another ER25 collet tool. As you can see, I haven't polished it or attempted to finish it. The object of this piece of metal is to collets fit in here. It's got a taper in it again. There's a taper in there. Collets go in there, and this goes in the vise on the mill. So it's a very easy and convenient method of putting flats at 90 degrees or 180 degrees, or 4 flats on a piece of steel on a round shaft. So you can put 4 flats on the end of a shaft very easily. Now, as you can appreciate, any oil that's on the surface is going to be dissolved in the brake cleaner. But of course it doesn't disappear. It's still in the rag, so I am reducing the amount of grease or oil on the metal, but it hasn't removed it totally, and the only way to do that is to actually wash this in quite a bit of solvent. Right, so we'll see if that makes any difference to the process. So we'll re-glue this piece. Get rid of that. We'll add another couple of mils of my precious bluing compound. I'm in New Zealand. This is made in the US, made by Brownells, and to import this into the country is quite a mission. And it's quite a few thousand miles away, so I'm looking after it. Right, so as you can see, this is taking much more quickly, but I think the end result's probably not going to be too different to that. Try something else here. We have a very second-hand bit of Scotch-Brite here, and I'll just use the tip of the Scotch-Brite and that worked very well. Got rid of the shadows on that surface quite nicely. And we'll do the threaded portion. I can still see there's a bit of grease and oil on here, because if it was completely oil free when I put the liquid on it, it would flow evenly over the surface without coalescing, and the surface would remain totally wet. And there are places where I can see that there's a slight little bit of oil on the surface still, but it's not making any difference to the end result. Okay, I'm just going to wash this in the hot water, and then we'll oil it. Right, we've got our oily rag back again. So there's the hot water treatment, and as you can see the surface is quite dry looking, a bit patchy, as you would expect. This is just a 10 grade general purpose oil that I use around the workshop, nothing special about it. Okay, that actually is not too bad. I mean, it's not gunsmithing quality, but that's because this is not polished. It's as it came off the milling machine. Okay, the surface, so this is the one that I cleaned up with brake cleaner. This one was as it came out of the lathe. They're different metals. This is free turning, and I have no idea what this is. So the metal, the parent metal is different, but you know the end result is on that one is still quite acceptable if all you want to do is make it rust proof. Now, what I will do is oil the inside here because that didn't happen. I could have blued the inside, it wouldn't have made any difference to the fit on the lathe because this pitting is only a few microns thick. I mean, this surface here is important because that mates up on my chuck. And in fact, in order to protect that, I've actually got another tool. Because this surface here registers on the nose of my lathe, I actually keep the tool screwed onto this when I'm not using it, so that I don't damage that surface when it's sitting in storage. And one has to be careful not to cinch that up because, believe me, it is a blued and ground fit, and if I cinch that up I can't get it undone. Well, I can, but it's quite difficult. Alright, so that is cold bluing, and I'm quite impressed by it. Thanks for watching.